Alright, so for this script, we are going to Webscrape transactional events that occurred in the NFL from the past decade. And what this means is that any player sign in, free agent moves, draft picks, anything that falls under that umbrella, we will web scrape off of the website we are going to take a look at shortly. So the first thing we do is, of course, import our libraries and packages. Nothing new in this first block here, but the main thing I want to pay attention to or take a look at is that we are introducing a new package called Selenium, and I never used Selenium before, and also web browser. These two I never used before, but the website that had the information I needed to web scrape had or really forced me to use these two packages. So if you're not familiar with Selenium is basically like a mock browser inside of Anaconda or inside of Python. So it'll allow you to give commands through programming or through lines of code where you could click on certain buttons or enter in certain links, and it'll act just like if you were browsing the web regularly, and you wouldn't have to click or move the mouse at all because Selenium will take care of that. But since this is a new package and library for me, this took quite some time to figure out. Like, just getting the thing to work at the beginning wasn't too hard, but when I had to make some adjustments to make it run a little bit more smoothly and perfect to my liking, it took quite some time to figure out. Maybe about a week or two, on and off, just thinking of how I could perform certain steps because this is a new library again, and I'm really new to this package, so I don't know everything, and there's some things where you just have to know or you won't get it at all. So just know Selenium within Python acts like a regular web browser. And that's the new library and the main library and package we are going to focus on. I don't know too much about web browser, but I know from my research I had to use these two libraries and packages. So we could move on to the next section of the coding after we have set up our environment and everything. And one thing before we get started and looking at the code, I should show you what the website looks like. So this is our website, Spot Rack, and this website is pretty good, but it's a very difficult website to scrape because of one thing, and I'll get to that in a second. So as you can see with this website, we're able to look at the NFL transactions, so we can see which players have just signed a contract, who has been waived, which players are going to be traded, and any players that have been drafted. But we want to look at data from 2010 to 2021. And this site, another thing that I don't like about this site is that it really bogs down my computer, especially running it on Google Chrome. They have so many ads running that it makes it very hard to work with this site, and that's why it took some time to figure out what I needed to do, because the site at some times would just freeze up and I would have to wait for it to unfreeze and get everything working again. But it's a very good website because it contains the data we need all the way from 2010, and even before that. As you can see, another ad pops up and it plays a video, and that's just gonna only further slow my computer down. So getting back to the main focal point here, so we can see which players have signed a contract for how much, for how long, or even which players have been suspended or even drafted. But the thing about this website is that first glance, when you come to this website, not all of the rows are loaded in. So we only have about, I think it may be about 30 to 45 rows that are initially loaded. And if you want to see more rows, you would have to click this button here, view more transactions. and that is how you get more rows to load. And we'll get to 2010 eventually, but there are so many transactions that occur in the NFL that clicking this one by one would take forever. And although we click view more transaction, when we go to our Python script and look for the amount of transactions to see if it has been updated from like 35 to 45, it's not going to update because the website or Python doesn't recognize that, we have clicked the new button on this tab or within our web browser, excuse me. So this is where Selenium comes in, because Selenium will allow us to constantly click that view more transaction button, and Python will recognize that we are clicking that button, and it's going to take in account all of the rows that are up to where we last clicked off. So let's go over this a bit. So we are going to use the Chrome driver or the Chrome browser. You could use, I believe, Edge, Chrome, Firefox as well. I'm not sure about Explorer. I don't know if they have that, but the main web browser I'm using is going to be Chrome. So we are going to add a couple arguments. So this argument here is very important because headless mode, we need Selenium to start in headless mode, and the reason for this is because if headless mode is not activated, or if we have non-headless mode here or non-headless here, we are going to see the actual web browser pop up on our computer screen, and we don't want to see that. We want the ability to click on the view more transaction button without even seeing the website page at all. So it's like something's happening in the background, and we just want to pull all of that data without actually seeing what the web browser is doing. It's just that we know from our script what our script is going to perform, or how many clicks are we going to have. And the other argument, and this is from my research as well, we are going to start in maximize mode. And basically, when I was researching, they said that if you start in headless mode and you need to click a button or anything, prefer that you also have this argument here where you start in maximized. And what this is, even though we can't see it, is that the web browser will take up the full size of the screen. And I believe it's based on your computer screen, so you don't have, or computer monitor, the resolution and everything. So you won't have to worry about really inputting the correct resolution. And you can see this is where we are setting up our driver. We are using Chrome driver, and there was some things I needed to install. I believe I needed to install Chrome driver from the internet, and we needed to install Selenium and web browser as well. So it's not something that's really plug and play. There's a couple settings that you have to go in and choose. Our options is going to be the Chrome options that we have here. So we're going to start in headless mode, so we're not going to see the browser at all, and we are also going to start maximized. So on to the next block of coding. We have a plethora of variables set up because this script was by far not easy to create because it was so frustrating. And the thing that was frustrating about it is that when I had Selenium in, or the browser in headless or non-headless mode, the clicks would work fine. Like clicking the view more button would work fine. But when we went to headless mode, clicking the view more transaction button, that did not work. It would give me an error saying that button did not exist. And after research, as I said multiple times earlier in the video, we finally got it to work. So we're setting up these variables, and just know that these variables are just basically counters and things that we need to keep track of. And we are going to set up a data frame, nothing new. We've seen this before. Okay, so the reason why we have click counter equal to 0 and click counter 2 equal to 1 is because for some reason in the loop, when I try to click multiple times without using the method I have in the loop, it wouldn't work. It would do something strange where it would just not register to click. So I had to create a condition where click counter is not equal to click counter 2, and that way it worked. We was able to click the view more transaction button and load more rows, and we are going to take a look at that later. So again, these are the settings that we've seen before, setting up our web browser, and then now we can begin to get into our loop. So for years in range of 2010 to 2022, we are going to perform all of these steps. So the first step is that we are going to convert the year, or we're going to create a variable called year, and it's going to take whichever position years is on and convert it into a string. Then we are going to take a placeholder link and then combine it with the year variable that we created earlier. So 2010 will be at the end of this link here. And we can see how that looks if I just type it in, because it'll be a lot easier. So now we have all of the transactions that happened in 2010. So that's a good sign for us that we are able to, go on different links or search through different links by the year. So once we get that, we are now going to put it in our browser, and I'm going to tell it to wait 120 seconds just to let the web page load up. And for some reason, I don't think this worked, because I noticed that it just continues to run the rest of the code without waiting 120 seconds. And I don't know why. Maybe I'm doing something wrong. And like I said, this Selenium library package, it's something new to me. So I wouldn't know why implicitly wait is not working correctly for me. Then we have this holder variable that we created on the outside and the inside of our loop as well. And what this holder variable is going to do is that every time when we click view more transactions, it's going to take a count of the total number of rows. So let's say the total number of rows the first time we visit the web page is 15. The holder list will get updated with a value of 15. Then when we click that view more transaction button, another 15 rows is loaded. So now the holder list will get updated with another value of 15 and 30. So we have two values in there, 15 and 30. And once we are no longer, or if we keep clicking and we repeat the same value twice, that means we have loaded all of the rows, because that basically means that there are no more rows to be loaded. And you're going to see how this works later on in our script in order for us to break the loop. So if years is equal to 2010, we are going to perform these steps. And this right here is the biggest thing and why it took so long for me to get this script to work. And for some reason, and I would have never figured this out if it wasn't thanks to Stack Overflow. And it was a Stack Overflow question that was hidden beyond the depths of the front page of Stack Overflow. This was something, I'm telling you, that took so much time to research, and I kind of luckily stumbled across it. So as I was mentioning earlier, when we start in non-headless mode, all the buttons are loaded properly and we could click fine, but we do not need to see the browser, so we start in headless mode. And the thing about headless mode is that all the buttons are there as well, but in my case, when we went to the website, there was one button that I had to get past. I had to, before clicking any other button, I had to accept the cookies on this website. If not, then that's why we got that error, and we were in the script, or the error message said that the view more transaction button did not exist. It is because we did not allow or accept the cookies and click that button, and that allows us to click the view more transaction button. Hopefully that makes sense, but it was such a very small detail that could go easily missed. So once we click that, we can now move on to our next set of instructions. So as I was mentioning earlier, we set up another loop while click counter is not equal to click counter 2, and these two numbers will never be equal because every time they are going to get 1 added to them, and we are starting with click counter at 0 and click counter at 2, so they are not going to equal each other. And I tell the browser to wait 120 seconds to let the web page load up and load all the buttons. So now this is our view more transaction button, and when you go to inspect, this is the attribute value, I believe, of the view more transaction button. So when we click in headless mode, it is going to click view more transaction, but as I was mentioning earlier, because we are in headless mode, we can't see that. The computer is doing that in the background. So like I said, if there were 15 rows to begin with, now we are looking at 30 rows. So after we click that, we go through the steps of, web scraping the Chrome browser that we are currently using. And I wanted to take a look at the transactions or the date of the transaction. I then wanted to see how many rows or how many dates were given in a single click. So we started off at 15. Now we're at 30, and that's where I say this count 1, we updated to the holder list on the outside that we have. So now 15, and then when we click again, it's going to be 30. So we now have 15, 30. We click one more time. Now we have 15, 30, and 45. If we come to a point, let's say we're in 2021, and 2021 is a new year, so there's not a lot of transactions going on in the NFL just yet. So if we click 15 and then we click 30, and then when we click again, we come across 30 again, that would mean that there are no more rows to be loaded, and we can move on to the next part, but we're not there yet. So I created a print statement just showing how many clicks we have, the amount of rows when we did click, and the year we are looking at. And then I added 1 to the click counter, and I added 1 to click counter 2. Then I say if click counter is greater than 1, which most likely or every time it should be greater than 1 because we are ultimately adding 1 to the click counter. So this statement is true if click counter is greater than 1 and the last position in the holder list is equal to the second to last position in the holder list as well. If those two are equal, then we are going to reset click counter to 0 and click counter 2 to 1. Then we are going to break the loop. And as I was mentioning earlier, that means we have loaded every single transaction and we can move on to actually web scraping this page. And that is exactly what we do here with page soup 2. We are going to use an HTML parser from the driver.pageSource. And this is something that was new to me as well because I didn't know you could do this with Beautiful Soup and Selenium. So this was something that was pretty neat. So now we are going to take a look at the date the transaction occurred, the player name, and the transaction reason. Why the player was moved. Like, was it because of a trade, suspension, or anything under that umbrella? Then we move on to our next loop. So I say while k is less than or equal to the maximum number in our holder list, we are going to perform these steps. So we have the date of the transaction. We are going to retrieve the text for that. And you can see we put the variable D for the position. And as I said, they are going to look at where we need to get each text for our specific reason. So the date of transaction, we can start at 0. The player name, we have to start at 5. The transaction reason, we have to start at 7 to retrieve that text. We also have the player profile link, which I thought would be handy because we have so many players we are scraping, and scraping the player profile link, it's not going to be hard and should enhance to this project as well. So we're looking at the A tag with the hypertext reference, and L is at the position of 5. So once we have the player profile link, we then can go one more step and grab the player profile picture, which we do later on. So you can see we create a staging data frame, and then we create our columns, and all of the necessary values we have, or all of the values we have scraped, are then inserted into the staging data frame, then appended to our transaction final data frame, which is on the outside of the loop. Then we add 1 to D, 1 to N, 1 to P, 1 to L, 1 to K. And if K is equal to the max number in the holder list, we then are going to reset all of our values and reset the holder list to be an empty list again, because this would represent we are moving on to a new year, and we don't know how many view more transactions or how many transactions in total are going to be in that new year. After that, we close the driver, but that is after the loop is completed. Once that is done and we close the driver, we do a bit of data manipulation here, and I tried my best to get the player position, but it's kind of difficult because the player position is under one line or under one text. So yes, I could scrape the last two positions, but we have to keep account that the positions are not always 2 characters. As you can see, Mike Rivera has 3 characters, and we don't want to pull an extra character that is not necessary, like this comma here, or even a S here, and then the comma, and then CB. So I tried my best with it, and I have to look back to see if it was perfect, but for the most part it did its job well. Then we are going to scrape any trailing and leading spaces from the position column, and more data manipulation here, things we've seen before. Lastly, I'm going to convert this date of transaction to date time, just so that it is recognized as a date. And then we are going to chop it up, take the year from the date of transactions and create that as a new column. And then we are going to get the team from the transaction reason. But the one thing about this is that because this is under the same line as the transaction reason, I decided to grab the last 6 characters and to the end, but sometimes that'll work, sometimes it's not going to work, so I'm not really too worried about it. This is something I just wanted to experiment with. So we do data manipulation again, or data cleaning up the commas or removing the commas, stripping any other characters that do not need to be there, and like trimming down any unnecessary spaces. After that, we then export it to a CSV file, and it's going to be called NFL Transactions. And we can take a look at how this data set looks. So you can see we have the date, the player name, the reason, the transaction reason. We have their profile link, the position, and the year the transaction occurred in, and the team. But the team is not perfect, I would say. There may be some instances where the team does not exist, like this EATS. This is because Alvin Kamara was fined, and the last 3 letters that it took, or the last 6 characters that it took started from EATS. So that's why I say it's not 100% perfect. It just really depends on the transaction reason. Like this New Orleans ones here, it's fine because they have NO at the end. You can also see that we don't have all of the player pictures available, and that is something I wanted to scrape as well because I want to add it to the Power BI report. So this is not the final export, we do a lot more. We do more within our program. So the next thing we are going to look at is, of course, retrieving the player picture. So now we are going to load in that data set we just exported, and I only want the player and the player profile link. And then we are going to drop all of the duplicates. Once we do that, we reset the index, so now we have an index, and then we create several variables. So I is equal to 0, t is equal to 0 as well, p is equal to 0, and then the total, we create a total variable, and it's going to be equal to the length of the amount of unique players in that data frame. So if we have 30 unique players, it's going to be 30 here. Then we create two more variables or two more columns within that new data frame we created, and we are going to call them player pick and player clean. And they are going to be both a empty string to begin with. So while I is less than or equal to the length of the unique names player column, we are going to try and perform these steps. So the first thing we need to look at is the player profile link. And we've seen that before when I opened up the CSV file. We had a link for all of the players. So if you go to the link for the player, they should have a headshot. If they don't have a headshot, it'll be just a default headshot, which is fine in our case. So we're starting from 0. So we're looking at the player profile link. Once we do that, we're going through the steps of reading the website page, parsing it, and then grabbing the information that we need. You can see we're looking at the image, and it's going to be the third image on every player page. And then we're going to get the src tag, and that is going to be our picture. Now the picture is of course in a HTTPS format, so we don't have to worry about downloading a whole bunch of pictures. And then also I just wanted to get the player clean name, and that's basically what we're doing here in these next lines of coding. And then we are going to update our data frame at the position of I with those new variables that we created. So the picture is now going to update the first row of our data frame with the player picture, as well as the player name that is cleanly scraped. Once all of that is complete, we are going to add 1 to I, and then I have a formula, or I have several formulas that just basically show the percent that has been completed. And if Q is greater than or equal to T, we are going to add 5 to T, and it's basically going to print out what percent we're on. So like 5%, 10%, 15%. And keep in mind, we have scraped data from 2010 all the way up to 2020. So I don't remember off of the top of my head how many unique names there are, but it had to be in the thousands. So it's going to take some time for this script to run. So once we do that, I ran into another issue where some players' picture was not captured. So I had to basically do the same step again, but only with those missing players. And we take care of that here as well. There weren't too many missing players, and there were some players I had to clean up, and that's what we do in this final block of coding. We're doing some data manipulation. We merged the NFL transaction CSV file that we opened earlier with the data frame that we have now. So now in our last block of coding, we are going to read in that CSV file that we were viewing earlier, and then we are going to merge it on our unique names data frame with the columns of player profile link, player clean, and player pick. And the column we are going to use to join in is the player profile link column. and it's going to be a left join because we want to see everything in the NFL transaction table and anything that is in the middle as well. So once we do that, more data manipulation and more data cleaning. So we have NFL transaction clean, player pick underscore Y, and we had a couple of NA values again. So we just have to set it up with a default player headshot. And then for the person that had NA values, his name was Richard Cleat. I believe he was the only one, and I don't know why it was just not picking him up, but in the end we were able to fix it, and so we took care of him. And then later on I go to set the player column equal to the player clean column, so this way we get the clean player name, so it makes it a lot easier later for us down the road. And then I drop two columns. I drop the player clean column in the player pick X column because when we merge data frames, sometimes the columns will come over and they'll create duplicate columns if we have two of the same columns in two data frames, and so it has to name it either X and Y, or Y and Z, or whichever. So we just had to delete one of those columns. And then I rename the player pick Y, so this was the other column, to player pick, and we set it in place true. And then we export this data frame to a CSV file with the encoding of CP1252. So let's take a look at this data frame here. So now we're looking at the final CSV file. So you can see it's kind of the same thing that we've seen before, but now we have all of the players who have participated in the transaction from 2010 all the way up to 2021. And let's look for a player because just about every player has been in a transaction. So you can see Salvan Ahmed. This is one of my favorite Dolphins player. I don't know if he has a picture, but we could check that out here. If he doesn't, that's fine. We'll look at another player that is a bit more noticeable or more recognizable as a name. So yes, this is Salvan Ahmed, and this is exactly what he looks like because I watch the Dolphins play just about almost every week. So that picture is correct, which means that his player profile picture is correct. And he did play for the Miami Dolphins, as I was saying earlier. I watch the Dolphins every week, so I know just about every transaction that they go through. So we can clear that. And that's it for this data, or that script there, excuse me. And that's it for this script here and the CSV file. But now it comes back again to where we have to look at it for the current season, and this is going to be a reoccurring theme throughout this project. We need to be able to run the code multiple times for this upcoming NFL season, and we do exactly that here. So I created another script called NFL Transaction Season, and it's just basically going to look at the current year we're in. So you see I set that up a little bit more differently. Before we had it as a static number. Now we're looking at the current year we are in based on my computer. So we're in 2021. If we were in 2022, then this script would be updated to 2022 and then perform all of the regular steps. And I also have this script running every day, I believe, at around 6:50 to 7 p.m. But we're going to see that later on when we get to the task scheduler and seeing which scripts I have set up to be ran daily, weekly, or even monthly. But that is it for these two scripts, and I'm hoping my explanation was enough. Even though it was a lot, it's a lot of details that went into creating this script here, and like I said, this was no easy script to create. very long and took a lot of research, but it was definitely one of the more rewarding scripts, or I would probably say it was the most rewarding script I ever created because it holds so much information and I can see what's been happening around the league. So I really like creating this script and I'm glad that it worked out in the end. So we can move on to the next data set now.